Hello, geometry. Good morning. Happy snow day. Please excuse my voice. I definitely have some sort of cold situation happening, but I'm getting better. So, what I wanted to do is make a quick video to talk about the example problems from lesson 7-2. So, I'm just going to do a quick review. Where we left off, we were talking about similar triangles. Similar triangles have corresponding angles that are congruent and corresponding sides that are proportional. Okay? We talked about three shortcuts. Angle, angle, which tells us if one triangle has two angles congruent to another triangle, then the triangles are similar. Side, side, side tells us that if all the sides are proportional to each other, the corresponding sides, then we have similar triangles. So here's how I would show that. Like I'll call this side X, side Y, and side Z. And what I'm going to have is some sort of scale factor. So I'm going to call this AX, AY, and AZ. And what I would look for again are setting up proportions and getting either equal cross products or simplifying those ratios to make sure that they are the same. And then side angle side similarity is two sides that are proportional. So we have an X and an AX, a Z and an AZ, again, A being our scale factor, and the included angle. All right, and that gives us similarity shortcut. Side, side angle, still not a similarity shortcut, and so we don't have to worry about that. And again, how did the similarity shortcuts compare with the congruent shortcuts? Essentially, all the congruent shortcuts are also similarity shortcuts, and then we added angle, angle because that produces a dilation. Doesn't produce similarity. All right, so write a statement of similarity and identify the shortcut you used. So when I'm looking at this, what I notice is that I have two congruent angles, but the sides in between, the side in between, I have a missing piece. And then I don't have two sides and an included angle. So the shortcut I would use is angle, angle. And the way I would write my similarity statement, again, matching up corresponding sides. It's up, or corresponding vertices. It's up to you how you want to write it. But I might say something like triangle DIL is similar to triangle PAC by angle, angle. And then to find G. So what I'm going to have to do is set up a proportion. And it's up to you how you want to do it. You have to find corresponding sides. So G is in between the two congruent angles. So G corresponds with segment PA, which is 9. So I'm going to write G over 9 equals, and now I have to find another pair of corresponding segments. And so since I started with triangle DIL, I'm going to go back to that triangle, and I'm going to pick segment DL, which is 4, and that corresponds in my second triangle with segment PC, which is 6. I like that a little bit better. I just didn't want to bother with the fraction. Again, you have a couple options here. You can use cross products, and you can get 6G is 36, which tells us G is 6. Or you could simplify 4/3 is a 2 to 3 ratio, and then you could think of multiplying by 3 to get to the similar ratio and also get G is 6. The other thing I also like to make sure, it looks to me like segment PA in triangle PAC is the middle length side, right? 6 and 10.5 is 9. And so I should get a segment for G, a segment length, that is in between 4 and 7. And I do. And so all those things help me check my answers. All right. Number 2, same idea. All right. So I'm noticing I don't have any angles marked congruent. However, I do know these angles are congruent. And can you tell me why? They're vertical. Very good. So vertical angle conjecture. And so now what I want to check again is check my sides to see if they're corresponding sides are proportional. So looking at this, again, what I have to do is make sure I'm matching up corresponding sides. I notice that this is 9 and this is 6. So segment BC is the shorter of the two sides, and therefore it wouldn't go with the 13.5. It wouldn't go with the 20. And so I'm going to check that 6 over 13.5, does that equal 9 over 20.25? Again, I'm going to check this with some cross products because I feel like that's the easiest thing to do. Okay, so I pulled out my calculator, and yes, I do have proportional sides. So what I'm going to write is triangle ABC is similar, so ABC is similar to triangle EDC by side angle side. Now, I can use this to find the length of AB. I'm just going to set a variable, we'll just call that X. So I know that AB corresponds with DE. And then again, it's up to me to choose the other side. Now, none of these are particularly awesome because they have decimals, but we do have our calculator, so it's okay. Again, if I'm going to start with triangle ABC, I'm going to then make sure when I do my next ratio, I put triangle ABC on top. There are multiple ways to set up a ratio. So just because your ratio doesn't look like mine doesn't mean that you're doing something wrong. All right, so I said x over 22.5 equals 6 over 13.5. I'm going to cross multiply. So I have 135 is 13.5x. And hopefully we all recognize this as 10 and x is 10, which means AB is 10. Again, looking and double checking that that's the longest side, largest side, and it is. All right, so number 3, I want you to notice that we have a trapezoid because we have one set of parallel sides and we have the diagonals of the trapezoid. So that actually does produce similar triangles. Why? Well, when we have our parallel sides, we know that alternate interior angles are congruent, and we also have a set of vertical angles here. So they is similar by angle. Now we can use that to find the lengths of segment S and T. So again, we have to be very intentional about understanding who corresponds with who. So this is actually like a rotation. If I was going to draw, so this angle here corresponds with this angle here, which means 70 and T correspond. Kind of think of it as a rotation. So I would write T over 70. I like to start with my missing value on top. And then the only other sides that I know are corresponding are the 36 and 90. Remember, I can't have two variables in my proportion, just one. Because I started with triangle GOS, I'm going to put 36 on top of 90. Again, if you want to simplify 36 90th, you could do that, or you can just run your cross products. Sorry for that pause there. I was pulling out my calculator. So T is 28. Now that I found T, if I wanted, I could use that in my next proportion. Or I could just go back to what I had before, knowing that I have S over 48. So because I'm starting with triangle RFS this time, if I want to use my same ratio, my same 90 and 36, I would put 90 on top. Then S is 120. All right, so I hope that when you check this, things are going well. I have a Kahoot for you to try to practice the skill more. So please do that, and I will see you in class soon.